Hi everyone, it's Stephanie. I'm coming through with the study session for tomorrow. If you're not able to make it to the study group and you take an early weekend, this will be up on YouTube and then you can just check it out. These are pretty much all the questions from the last lecture. And so, yeah, let's get started. I'm going to do my best to zoom in on the questions, but you can always check this out later because I'll take a picture of it and and I'll have a link to it and you can look at it and you can study from it. Yay, you'll get an A. Okay, so remember pretty much our last lecture, right? And I'll try and keep this short to 20 minutes, hopefully less. I'm essentially trying to take an hour lecture down to 20 minutes, so wish me luck. Okay, so remember, okay, the end goal of glycolysis, which is what we reviewed last week, is to get energy. The end goal of that energy is pyruvate, right, to ATP. So just like if that comes up as a question, the main meat and potatoes that you want to remember is that you have pyruvate and ATP, which is a source of energy that is going to be the end goal of glycolysis. So let's jump into this. Okay, so name two ways you can make ATP, all right? And this is actually kind of a trick question, but this came up on the last lecture. One way is substrate level phosphorylation, which we'll see in glycolysis. And the next one is oxidative phosphorylation, which we are covering on Thursday, the next lecture. So just stay tuned for that. So oxyphos and SLP. That's how I like to remember them because they're super long names. Okay, next question. Which is associated with glycolysis and which is associated with ETC? ETC, by the way, electron transport chain, all that is another pathway in which energy can be obtained. And then you could just do a quick Google search, but I won't get into the depths and details because we didn't go deep into that into class. Right now, our focus is glycolysis. Okay, so remember, glycolysis is associated with the substrate level phosphorylation, and we'll see a lot of that during glycolysis, whereas electron transport chain is associated with oxyphos or oxidative phosphorylation. Okay? Okay, now the next question is, we'll talk about vitamins, right? And as many of my buddies are going to be dietitians out there, so shout out to you guys making everybody skinny. But we got to understand what the importance of vitamins are. And so my question is, what role does vitamins play? What role does vitamin play in terms of the body? And I think we all know it's going to be metabolism. Vitamins play a role in metabolism, right? Because you have to think about exactly where the mineral, right, is going to enter into the process to begin glycolysis, and we'll get more in depth into that. So now that we know that vitamins play a role in metabolism, vitamin D is a precursor for coenzyme A. Okay, and we'll get in depth into coenzyme A. So let me just write this over here. Okay, yeah. Cool. And so next, breaking things. So the next question is, we gotta get into the actual understanding of reduction and oxidation, okay? If you remember, reduction, right, is when you're going to be getting an electron or adding a hydrogen. So reduction is loss and oxidation is gain. I just remember it by oil rig. Reduction, OIL, reduction, RIG, and oil, OIL, oil rig. So reduction is a loss of electrons and oxidation is a gain of electrons. And why is that even important? When you're talking about the glycolysis, we're going to come on two really important molecules. One is NADH and the other is FADH. And these are both, can you fill in the sentence? These are both electron carriers. They're going to essentially be electron carriers, and they will end up on O2. They will end up on oxygen and leave as water. So yeah, let me just write a little thing for that. And Next question. So, niacin and riboflavin, these are two other very important vitamins that we need, and they're more or less essential, or just important. I should probably say important other than essential. But niacin is a precursor to NADH, and you can just remember N and niacin, NADH. And then riboflavin, right, is a precursor to FADH. So you can think riboflavin is a precursor to FADH. So let's jump into the really quick questions that I think are going to be important on our test. If you're out here watching from another place, maybe this will help, maybe it won't, but I'll have a picture of this and a link to it, and you can copy it and share with friends and laugh at my hair or whatever you guys want to do to try and learn from this. Okay, so what are we doing? Okay, so quick questions for about glycolysis, and this is based on our last lecture. So remember, whenever we hear kinase, what does kinase have to do with what? When we ever talk about kinase, go ahead and try and answer in your mind before I tell you the answer, what kinase does. Okay, have you got it? Kinase is associated with phosphate, and it's essentially the Uber for phosphate. It makes sure to transfer it, it adds it, it can remove it from ATP. Phosphate is pretty much like the Uber for kinase is essentially the Uber for phosphate. So that's something that's important. Okay, and then isomerase, right? Isomerase is another enzyme, right? These are both enzymes. Isomerase essentially it will change, has the ability to change. Remember, we have isomers, right? That you have a molecule that is a same molecule but different connections. So isomerase pretty much has the ability to change around connections, and that's my understanding of it. And you will see that happens, like say you have something on carbon 3, then you go from carbon 3 to carbon 2, then that isomerase has changed the connection, right? Still the same molecule, but move things around, okay? So let's jump into step 1. Step 1, you have hexokinase, right? And my quick question for you, is this irreversible or reversible? The answer is irreversible, right? It is irreversible. And what does that mean? You're going to see an arrow go one direction instead of back and forth, okay? And then also, is it exothermic or endothermic? Boom, it's exothermic because it's releasing energy. Step 2, and by the way, it releases about 16.9 kilojoules of energy. So that's going to be important because you have to know about energy release when it comes to different steps along the pathway to get to the end goal of pyruvate and ATP. All right, now let's talk about step 2. Step 2 is glutathione, right? Glucose to fructose. Okay, that's a transformative type step. And really, my question for you is, if you see these arrows, what does this mean? If you can't see what I'm pointing out, I'm basically making an arrow going this way and an arrow going that way. So remember, if you see an arrow going this way and an arrow going that way and they're together, that means it's reversible, right? And so that's going to be important to realize that if you have an arrow going just one direction, that's going to be irreversible. That's exothermic and releasing energy, whereas back and forth means the opposite, or more or less, okay? So let's move on really quick to the phosphofructokinase reaction, which is the major point of, and I'm going to leave that blank, it's a major point of regulation. Regulators, hey, that was lame, but okay. Anyway, the really important thing about phosphofructokinase reaction is that it is the major point of regulation in glycolysis. Pretty much when you get here, glycolysis is happening, okay? And we have other regulatory mechanisms where, say, for example, if it gets to a certain point, it might not even go through because you already have too much ATP. And so let's take a look at what that looks like. So we've already expressed that phosphofructokinase reaction is the major point of regulation, and it's the committed step, okay, that will go through glycolysis. Once you reach this step, this is the step that's going to ensure that glycolysis is going to take place. And so let me pose a question. A high amount of ATP levels will shut down blank, which will slow down blank. Can you take a guess? 3, 2, 1. Okay, this could have been a tough one, and it's okay if you didn't get it, but let's give it a try. A high amount of ATP level will shut down the phosphofructokinase reaction, and it will slow down glycolysis. Okay, and that's going to be important because of the fact that glycolysis is going to be your mechanism of trying to get pyruvate and ATP. And so this is going to be important to understand the fact that we have a regulator, right? This is going to be an inhibiting factor. And so let's think about it this way. If you have a low level of ATP, if you have low level of ATP and a high level of ADP and AMP, right? This is adenosine phosphate, and this is adenosine monophosphate. So if you have a high amount of this will positively regulate the enzyme, right? Basically, essentially, it's just essentially saying that this ADP and this AMP can stimulate, that ATP is stimulated by ADP and AMP levels. So if you have a high amount of this relative to ATP, then you're going to get a stimulation effect, and high amount of this ADP is going to possibly or more than likely lower the levels of ATP. Do I have that right? Yeah, low levels of ATP is inverse with high levels of ADP. So I think the most important thing to understand here is that there's an inverse relationship between ATP and ADP. And the reason why this is going to be important is the fact that inhibition is occurring, right? Meaning essentially that pretty much like, just say, for example, I want to try to make this easier. ATP, right? If you have so much ATP already floating around, you have this is like a really kind of an unstable molecule that is pretty much can make the cell do work. If you have a high amount of that, why would you need to go ahead and make a whole bunch more when you already have so much? So you don't want to over ramp that pathway. So hopefully that makes sense, and I can go deeper into that. If you have questions, you can make comments and I'll clarify. Okay, let's move on. Let's talk about the aldolase reaction, okay? The aldolase or lyse or splitter, right? I like to think of it as splitting or cutting. Well, this is the reaction that's going to take a long sugar and cut it into 2 3-carbon sugars. And so this is going to be a reversible reaction, meaning that it can go backwards and forwards. And then, so from here on out, right, we're going step by step by step. Now each reaction will be multiplied by 1, 2, 3, or 4. You could safely say it's 2, right? Because the aldolase split that long sugar into 2, okay? So let's keep going. Okay, so hopefully this is visible, but again, I said I'm going to provide a picture so that you can read along if this is hard to see. NADH, let's talk about NADH again really quick. The thing you're going to really want to remember, because we have to keep tabs of pyruvate, ATP, and NADH. Sorry, yeah. Pyruvate, ATP, and NADH. We got to keep tabs on that because you might get a question of how much do you have here? How much do you have here? So that's going to be important. Okay, so remember, this is an electron grabber. And remember, so let's move on to the next question. So the process by which phosphate added to ADP to make ATP is called what? I'll give you a second. Okay, so The process by which phosphate is added to ADP to make ATP is called substrate level phosphorylation, okay? And the fact of the matter is we're taking, this is a molecule that's been made that's incredibly unstable. We're taking it, putting a phosphate directly onto ADP, and we're making ATP. And that's really powerful because we're making ATP in the step, right? And so and in the last step, right, we actually take a phosphate, add it to the adenosine adenosine diphosphate, and make adenosine triphosphate. And this is an example of, again, substrate level phosphorylation. Sweet. And then for pyruvate kinase, okay, this is the last reaction. It has negative 31 kilojoules that is released. So is that endothermic or exothermic? Give you a second. 3, 2, 1. And it's exothermic, right? Because when you have negative and we have a release of energy, that means it's exothermic. Okay, so how is this associated with the Chatelier's principle? So if you look on the actual, if you have a chance to take a look at the actual pathway, one of the last steps, because it's, I guess the easiest way to understand it is that one of the last steps is going to use the fact that it's so energy, use the fact that it's so energy releasing to make the rest of the reaction go. And so the Le Chatelier principle talks about essentially if you have, if you have a stressor on one end, okay, Le Chatelier's principle says the stress wants to be relieved and moved to the other side. So if you put stress on one side of the equilibrium, if there's stress on this side, then it wants to relieve that stress and it'll move or it'll go forward, okay? So I can get deeper into that, but if that doesn't make any sense, I will probably make a follow-up video to talk specifically about that point because that's an important point to understand and hone in on. So, okay. Yes, so let me write that down. Cool. So next, what is the net product number per glucose for glycolysis? So I'm essentially asking about pyruvate, ATP, and NADH in terms of per glucose molecule, how many pyruvate, ATP, and NADH will we have? Hopefully your answer is 2, 2, 2. 2, 2. It's really easy to remember. Although essentially you're supposed to get 4 ATP, the net is 2. So that's going to be an important point, and don't get tricked by that. Okay, what else? Okay, so we have a little recognition game, but if I'm going to leave that to you when I take a picture of this and you can take a look at it, and your goal is to recognize which one is ATP, which one is pyruvate, and which one is acetyl-CoA. So take a look at those on your own and see if you can figure it out. It should be pretty easy. And yeah, the last part here that I have is just talking about glycolysis again. And I'm gonna just go through and ask some questions really quick that might help, that I remember that she posed during the lecture. So remember, right, with glycolysis, we have glucose that goes to glucose 6-phosphate. We make pyruvate in the end, okay? That, after that, we have 2 NADH that's made, and then that can go to acetyl-CoA, and guess what? Even that can go into the Krebs cycle. So there was a quick schema that was made there, and my question to you is, in terms of storage, okay, in terms of storage, what is the molecule associated with storage? Hopefully you say insulin. Insulin is glycogen. Glycogen is the storage molecule, and insulin is a hormone that makes storage occur. Okay, so storage occurs by glycogen, and let me just write that down here. Perfect. And insulin is a hormone that makes that happen. And then if you want to release glucose, then it is released with epinephrine or adrenaline or one of those types of hormones that cause a release. And so I can get deeper and deeper into these, but I think I'm going to hold off because we're getting really close on time. How many? Oh, we're already at 20 minutes. So I might just run really quick through these questions and then I'll make a separate video that you can check out. So quick, why is gluconeogenesis needed? The point is when we have low blood sugar, right? Then we're going to need more sugar into the body. And so gluconeogenesis is going from pyruvate to glucose. And that's going to be a really important point. However, okay, true or false, gluconeogenesis is the opposite of glycolysis. The answer is false because of the fact that, sorry, I meant reverse of glycolysis. So gluconeogenesis has irreversible steps. So we want to remember that and keep that in mind when thinking about trying to relate, glycolysis to gluconeogenesis and other pathways. So let's be careful. True or false? Amino acids can form glucose if needed. 3, 2, 1, true. Fat can form glucose if needed. 3, 2, 1, true. Just kidding, false. And then true or false, excess acetyl-CoA can be stored as fat. It is true. What else do I have? Yeah, that's pretty much all we have right now. We're going to do a follow-up tomorrow. And so stay tuned for that video. I hope this was helpful, highlighting some important points about glycolysis. And yeah, if this was helpful, let me know in the comments below. Let me know how I can fix, because I'm pretty into this, but I want to keep helping. And so thank you so much for checking out my channel. And yeah, stay tuned for more clarifications and fun videos and free handouts, because I got your back. Peace.